So Robert has been working, among other things, on the Postgres provider. You work on the MySQL provider as well, right? Or were you?
No, actually there's another person.
Oh, okay.
So, okay, I just have a few slides that I want to go over, and then we'll go into the demo. So as you've seen in Theo's presentation, I mean, if you know enough Postgres, you can pretty much act, to do whatever you want. But in this presentation, what I want to talk about is the dtrace provider for PostgreSQL, which allows you to kind of abstract, that lower level code that allows people who are not really familiar with Postgres to use the probes. So I'll just talk a little bit about the process that we went through.
After advance one slide, and then you hit pause, and then you
Okay.
you hit pause, or then just keep going through your slide. Now, because you've done that, now
You tell it.
So that is what.
Okay. Okay. So, as you all know, working with the open source community is a little tricky. Right? You can't just do whatever you want. You pretty much have to get their buy-in and get the developers to agree to what it is that you want to implement in terms of features. So when I first made the proposal to the open source community, one of the lead developers, like when I pretty much try to explain that the stable probe effect is no, it's like fucking no. There's no way that you can have no disable probe effect. So I had to go through all the explanation and pretty much show them the Unix paper and pretty much give him all the information that he needs to know to feel comfortable. And then with support from the community like Theo, he's pretty much very helpful in terms of explaining to the community that dtrace is really helpful in terms of helping him identify performance issue, memory leaks, and things like that. And that's when the developers starting to kind of feel a little more comfortable about adding dtrace into PostgreSQL. And then after that period, it just happened that the Postgres community had a developers conference. So I had the opportunity to present to them what dtrace is capable of doing. And until they see what dtrace is capable of doing, will they actually think that it's a very cool thing to put into Postgres. So, I mean, finally at that conference, we were able to get the developers to agree to put dtrace. And here I'm just talking a little bit about how we go about putting the probes in. So initially, my proposal was trying to make it more like a generic monitoring framework that will allow other operating systems to actually take advantage of this the APIs, if you will. So we went ahead and decided to use the old approach of doing USDT using the dtrace probe and actually map that into another macro called dtrace. And so essentially using that pretty much scattered throughout the code for probes. And for Solaris, we pretty much mapped it to the dtrace probe. For other operating system, pretty much a null statement, a null op. So the community, felt like that's a good solution, so that other operating system, if it has similar facility, that it can take advantage of it. But then came the dtrace support on Leopard, and right after Leopard came out, one of the users reported a problem with the provider not being able to compile dtrace on Leopard because the -G flag is not supported. So pretty much have to redo the provider to use the dtrace -H to generate the header file. And then again, with the generate macros, the community had an issue with the macro names, PostgreSQL, the provider name, and the probe name, because they see that as a macro to the macro that's used in Postgres itself. For example, for lock, you can see like PostgreSQL LW lock, acquire whatever. It doesn't seem very intuitive, so they want us to have like a trace in front of all the macros. So that had to be done. So actually, it's quite easy in terms of implementing a probe. I mean, the more difficult part is really the build environment, changing the build environment to allow this probe to be compiled and integrated. So the way we do it is pretty much in configure. When you configure, you just say enable dtrace, and when you do that, it generates the header file for you. And then actually to add the trace, initially I was planning on using Adam's Perl script. It turns out that that's a little more intrusive, so what we decided to do was pretty much just use a set script to prepend the trace name and from the generated macro. Okay, so right now we have a pretty limited number of probes in Postgres right now, and the original intention was just to get a small number of probes in so the developer can use them to identify performance issues. And with what we have in place, other people can recommend or suggest new probes to be added. So going forward, I think there's a lot of opportunities to add more probes, not just for the developer, but also for the DBAs, to be able to identify performance issues. So things that Theo shown earlier, I think we can actually come up with probes that we can integrate into Postgres. So we have these probes in now. So who uses them? So right now, the probes that we have are quite low level, so only developers or performance engineers actually can take advantage of them. And like for example, we have a Sun group that's working on Postgres, and they use that to identify performance issues. And some of the community members are now starting to express interest in using these probes to identify performance problems. And with Leopard now having dtrace, I think there's going to be more users interested in using the probes in Postgres. So some of the performance wins that we've been able to achieve from using the probe. For example, one of the guys in the Postgres, Sun Postgres team, has been doing a lot of benchmarking, and using the probes, we've been able to identify scalability issues in Postgres. And then locks issues and things like that. So future plans, some of the things that we're thinking of doing, of course, really, we're going to have to make a proposal to the community and get them to buy into this. It's actually to add more probes, like I said, not just for developers, but also for, like DBAs to be able to use. And also, using this, programming API to implement some of the, commands that's available in Postgres. For example, like explain analyze, the cost. So we want to be able to see not just the logical, read, for example, the physical one. If that happens, we want to be able to use dtrace to help identify this. And we've been thinking about like an auto tuning tool, because Postgres has this huge configuration file that you have to tweak to get the best possible performance. So we're thinking, maybe using dtrace, we can identify areas where dtrace can help tweak the configuration file. And then, there's also talks about coming up with common or standard probes for databases especially open source databases.
Yes.
And I know the MySQL folks, have worked on probes, and so I think it would make a lot of sense to come up with standard probes for the probes that can be common. And of course, there's a lot of probes that will be database specific.
Even if that's de facto, even if that's not, I don't think it needs to be overly rigid to still be very effective. I mean, even if we can just try to get, the MySQL folks and Postgres folks and the other, the commercial databases, if and when they wake up, to just where they can, but they shouldn't feel obligated to meet existing models, but it would be great. The more we can share that, the better.
Right.
The other thing to look at as part of that is also, at least to the degree that's possible, data type things that can be common. So you remember when Adam was showing like the NFS provider, there was a common set of, in effect, these pseudo data types that we have where there's a translator where arguments to those probes are provided and there's like a con info T or whatever that are basically common concepts. If there are some common abstractions for example, how to describe a SQL query that could be arguments to those things, that's a good thing to look at as well, because that would also help people, regardless of which database they're deploying, you can have different translators that have the same types and different implementations.
And further to that point, we could even have you have a MySQL provider and a Postgres provider, but you also have a database provider which has the lowest common denominator probes, so that you can write, so Brendan can go write scripts that plug into any of these.
Take yourself in.
Right.
Okay. So I'm going to show you a quick demo of the probes that we have right now in Postgres. So these are the like I said, the one low level accepted 3 transaction probe, transaction start, transaction commit, transaction abort. And so, for example, you can run this script to put some load on the system. So this just show you the new transactions. So new created committed transactions. Very exciting. And this other one. Show you the lock contention that's happening within the system or Postgres. So it runs for a few seconds, and then it show you the various locks here, and whether it's exclusive or shared, and the number of times that the locks actually.
And has this been useful for people who use this to debug database load problems?
Yeah, exactly. So one of the blocks that we identify is this properly lock that has been the cause the scalability issue with the when you increase the number of users in a benchmark test. Okay, so. I'm running this workload that sometimes hangs the system for a little bit. So, I mean, interested pretty much. This is the provider name we have, and it's pretty straightforward. So, one of the other things that we did to kind of make it less intimidating for people who are not familiar with dtrace is to integrate this with the jam tool that Tom comparison did. And so I'm going to quickly show you that how you can use time to actually visualize the data. It's a little more readable. Okay, so we pretty much integrated the dtrace script and created these displays. So for example, I can run the script that I ran earlier, and we have a little bit nicer looking output that you could sort by, like, this shows you the blocks acquired per second, and it shows you that this particular block, is a Wuhan block, and this is actually just counting the cumulative time.
Great stuff.
So, this is just the beginning, I think, and I think we have the opportunity to actually create a lot more probes, and especially the common ones that we can create that can also work with MySQL, as well as making like even a tool like this available to database administrator to use, so that instead of them having to write dtrace script to use this Postgres provider, we can make available this tool for them to use. So all they have to do is pick the display that they want to run, and they'll be able to look at it.
That will actually correlate queries with this output, so we'll know which query was which.
Yeah, that's a good question, and we thought about that. So right now, there's no correlation. I think that's something that we think about, is to be able to say, look, this particular query will cost, this kind of, I/O costs this kind of attention, and how long it would take to actually parse the query to execute the query, things like that. And that would be really cool, right? To be able to look at the SQL statement and be able to find out.
Would that just be sort of pulling IDs through the system then? Or is that just a question of sort of giving each query a UID and exposing it?
Yeah, so I think there's certain things that need to be done that I don't have the complete knowledge at this point. So, but I mean, that's one of the things that we've talked about. That's interesting. I think we can achieve that. And also, like Theo was saying earlier, like Oracle has all kinds of statistics that are available, and I think with dtrace we can essentially do the same thing in terms of collecting all kinds of statistics for any database, and make that available to the user.
Thank you. All right, so I think we're going to be able to, thanks to really interesting stuff on databases. Good to see some real world stuff out there. So I think on just so I know we're behind, I think on dtrace and visualization, I think we're going to be able to catch up. I think we can do kind of switch those things together. Because unless there's more demos than I know in visualization and distributed dtrace. So we can either take a break now and come back to dtrace afterwards, or we do go straight into the